What exactly are derivatives? The derivative measures how a function changes as the input changes. Basically, the slope of the tangent line, tangent to the curve at some point. So by the power rule, if we have f of x is equal to, say, x squared, then f prime of x is equal to 2x, right? And, we want to find, let's say at 1, f of 1 is equal to 1 squared, so we get the 0.11. And then y minus y1 is equal to m times x minus x1. Y minus 1 is equal to 2 times x minus 1 y is equal to 2x minus 2 plus 1, so minus 1. This would be at the point 1, 1. We can go to f of 2, which would be equal to 2 squared, or 4. F prime of 2 would be 2 times 2, which is also 4. And then y minus y1 is equal to m times x minus x1. Y minus 4 is equal to 4 times x minus 2. And I think we did this one already. Y is equal to 4x minus 8 plus 4, so minus 4. We can go to the third point. Let's say 3, 9 is the point. F prime is equal to, f prime of 3 is equal to 3 times 2. It's equal to 6. So y minus 9 is equal to 6 times x minus 3. Y is equal to 6x minus 18. 18 plus 9 is minus 9. Well, minus 18 plus 9. 6x minus 9 then. And these are the three equations for the first 3 points. We'll get steeper and steeper lines as a rough graph. Let's say this is 1, 1. That, and then it would be like that. Oop, that looked pretty bad. And like that. And then let's say like that. Just get steeper and steeper. We can do the same thing on the other side of the graph. The same process. It would be like for the point -3, 9. We have now the negative f prime of -3 is now -3 times 2, or -6, so it's going to be pointing in the opposite direction, but basically doing the same thing. Something like that. Some basic derivatives, I didn't talk about them in the last one, but trig functions show up a lot. The derivative of sine of x, let this arrow be d by dx, these arrows. So we get sine of x, that goes to cosine x. Cosine x goes to negative sine of x. and tangent goes to secant squared. Mostly because tangent can be written as a quotient, and then you can go from there. There's also the logarithms and exponentials. E to the x is its own derivative, which is pretty cool. I will not be proving that. If we have any other exponential, say 10 to the x, this becomes 10 to the x times the natural log of 10. And that is because of the property of logs. Natural log of a to the b is equal to b natural log of a. And we can write 10 to the x as e to the x natural log of 10. And then taking the derivative of that is just, the chain rule, which would be 10 to the x times natural log of 10. We did the power rule. X to the negative 1, using the power rule, would be negative 1 x to the 0 divided by, well, not divided by, sorry, that's wrong. Just something like that, but we know that that's not the case. Actually, the power rule fails for that, and no, wait, shoot, no, that's wrong. That's totally wrong. But when we take the natural log derivative, this is equal to 1 over x. Ignore that. Now, when we take the derivative of any other logarithm, it becomes natural log of x divided by the natural log of 10, and that becomes 1 over x natural log of 10. This first step isn't a derivative, it's just rewriting it. Some more derivatives that show up, mostly when it comes to like integration and other stuff, but the arc sine becomes 1 over the square root 1 minus x squared. And then there's the arc cosine, which is the negative of it, and arctan. These just give the slope of the tangent line at some certain point. So we had our trig functions, our exponential, our almost wrong power rule, natural log, and other logarithms, and then our inverse trig functions. And that's basically everything. Thank you for watching.